I'm going to record some videos on all of problem 2 from homework 7. I feel like people got probably most of the parts, but we're missing some. But also, even the parts that people got, there were some weird things about it. Just so that there's no more questions about that, here's a full explanation of problem 2 with all the parts. And I might have different numbers from you, but hopefully just pay attention to the concepts, and hopefully that'll be fine. All right, so let's look at part 1, the first question on problem 2. And here are the numbers that I had. So they gave me a 4,000-pound car. The effective spring constant from 4 shock absorbers was 26,000 pounds per foot. And the first part said there's no damping. They want you to find the period. And then there's this weird thing that says hint, G equals 32 feet per second squared. Okay, so really weird and obscure physics stuff using imperial units. This came up once with newtons and kilograms and units that we're used to. But what they're talking about here is a 4,000-pound car. Pounds are not a unit of mass. That's what's going on. So M is not 4,000. Pounds are a unit of force. So pounds are analogous to newtons. And we know that newtons are kilogram meters per second squared. Our pounds, I had to look this up. There's a thing called a slug. That's the unit of mass in imperial units. It's a slug foot per second squared. So when you get on a scale and it measures in pounds, that's not measuring mass, that's measuring force. That's why there's jokes about, you want to lose weight, like get in an elevator and go down, or go to the moon or something. That's what they're talking about. You will lose pounds. You will not lose any kilograms. Very weird. And like the pound, we say 2.2 pounds equals 1 kilogram. That's a lie. That's only on Earth. And it even varies slightly at various places on Earth. So we want M in slugs. So we want M times G is actually 4,000 pounds. And so your mass in slugs is going to be 4,000 divided by 32, which is going to be 125 slugs. So our differential equation is actually 125 y double prime, no damping, they said, so no y prime term, plus 26,000 y equals 0. And then if you have the formula for frequency memorized, you could finish the problem here. I'll show it both ways. So frequency is the root of k over m, which is root of 26,000 divided by 125, so root 208, which is 4 root 13. And then if you have this memorized too, your period is 2 pi over frequency, which is pi over 2 root 13. And now we are in seconds, and then whatever abominable decimal WebAssign likes, you convert it to that, and it's happy. If you don't remember this, there is a way. There can be an argument made for memorizing this. I don't have a very strong opinion either way, but we can get it with the characteristic equation and solving the differential equation. So R is going to be plus or minus 4 root 13i. So purely imaginary roots, which means our general solution is y equals a cosine 4 root 13 t plus b sine 4 root 13 t. I'm kind of reviewing this too to remind you of how we got here, because I feel like we didn't talk a lot about this. But what's going to happen now is you're going to write this as a single cosine, and if we had constants a and b, we could figure out what these other things are going to be, but it's going to be some constant c times the cosine. This part will stay. It's going to be 4 root 13 t minus some number delta. And then the delta just tells you shifting left and right, so we only care about this. I don't have anything about the period memorized in general when I'm graphing. sine and cosines, but for root 13, t has to go from 0 to 2 pi. Because then for root 13t minus delta will go from, I guess, negative delta to 2 pi minus delta. So that's still one whole period. That's a 2 pi length period. Which means I can divide everything by 4 root 13. So t will go from 0 divided by 4 root 13, which is 0, to 2 pi over 4 root 13, which is pi over 2 root 13, which is the same period I got here. T goes from 0 to this, so that length is the period. You don't have to do this extra work if you have this stuff memorized, but this does show where all that comes from.